Hello and welcome to today's lecture. Today we're actually going to jump into factoring polynomials. To do so, we have to understand how we divide a polynomial by a monomial. So we're actually covering two sections today, and that is section 5.6, which is the dividing polynomials by a monomial, and section 6.1, which is greatest common factor and factoring by grouping. So go ahead and get those notes ready because here we are. I have my first problem already written for us. Let's assume that I have a polynomial, which is 12x cubed minus 15x squared plus 3, and I am dividing this entire polynomial by one term, which is 3. So I'm dividing by a monomial term. What I'm going to do is I am actually going to split this problem up so that I have my individual terms divided out. So I have 12x cubed divided by 3 minus 15x squared divided by 3 plus 3 divided by 3. So I'm simply taking my polynomial, I'm splitting it into pieces because remember, I'm adding and subtracting here. So when that's in the numerator and I have just a single term in the denominator, I can split this up. And so what I'm going to do is simplify as I go. Looking at what I have for this first term, 3 goes into 12 nicely. That's 4x cubed. Excuse me. 3 goes into 15 very nicely here. That gives me 5x squared. And 3 over 3 is 1. Now this little polynomial is already in descending order. There are no other like terms to combine. And so you are done. That is a great example of how we simply divide a polynomial by a monomial term. Let's try another one. My next example, I have 32m squared n squared minus 20mn cubed plus 24m squared n, and I am dividing by 8m squared n. Okay, so I have a lot going on here, it looks like, but what I'm actually dealing with is a trinomial, so three-term polynomial on the numerator, divided by a monomial, even though you see multiple variables. Now, what we're going to do is we're going to split it up just like we did before. I'm going to work vertically for this problem, so it's a little easier to see. So I have 32m squared n squared divided by 8m squared n minus 20mn cubed divided by 8m squared n plus 24m squared n divided by 8m squared n. Now, again, I got a lot going on, but take it one step at a time. So what we're going to do is we are going to simply divide out our coefficient values here and see if our variables will simplify at all. So 8 goes into 32 perfectly 4 times. M squared and m squared will cancel completely, so that's nice. N squared divided by n, that means, think about quotient rule, that's 2 minus 1, right? So that would just be an n that you are left with. Minus, because we didn't drop the negative at all, 8 does not go perfectly into 20, but instead they can both simplify by 4, which means that would give me 5 over 2. Now let's talk about where our variables land. I have m over m squared. Only one of these m's will cancel, leaving me an m in the denominator. I have n cubed over n. Only one of these n's will cancel, leaving me an n squared in the numerator. Very good. Now, let's go over to this side. 8 goes into 24 perfectly, 3 times. M squared cancels. N cancels. So I'm left with just 3. And so whenever you divide by a monomial term, not always are you left with perfect little results. You don't always get whole numbers or integer values. Sometimes you will get fractional values, and that is a-okay. Now, that being said, let's do one more example before we start talking about factoring. And I think I got enough room right here. We'll just put it up. So I have 8x squared y squared plus 16xy plus 2x. And I am dividing this by 4xy. Excellent. Now, same thing. We're going to split these up, and then we are going to look at how these individual pieces break down. So I have 8x squared y squared divided by that 4xy, plus I have 16xy divided by 4xy, plus I have 2x divided by, you guessed it, 4xy. For this first term, 4 goes into 8 perfectly 2 times. X squared and x leaves me an x in the numerator. Y squared and y gives me a y in the numerator. Plus, 4 goes into 16 perfectly 4 times. Xy cancels with xy, leaving me just the 4 there. Plus, in this case, 4 does not go into 2, but I can simplify both of these by 2. That leaves me 1 over 2. My x's cancel, but that leaves me a y in the denominator. And there we are. So dividing out your monomials, dividing out your polynomials by a monomial sometimes, again, leaves you those fractional values, and that is okay. You just attach them wherever they fall. Now, we're going to jump into section 6.1 at this point, which really jumps into the idea of factoring. And the first thing about factoring that we really have to understand is the concept of greatest common factor. Now, greatest common factor is very simple, though it does take practice to identify GCFs, or greatest common factors. I'm going to go ahead and get all my board space here. Okay, so now looking at my GCFs, one thing that I want to point out is that you already have a definition at the very top, and it has an example written out for you. So I'm going to start with these examples to help flesh out the idea of a GCF. So the first example that I have is 16y to the fourth plus 8y cubed. When I'm talking about the term greatest common factor, what I'm looking at is what numbers, coefficient, and what variables, greatest number of those, that I can pull out from all terms of my polynomial. So in this example, I have 16y to the fourth, 8y to the third. What is in common? Let's start with the coefficients. I have 16, I have 8. 8 can go into both of these terms. Okay, so that means I have a GCF that contains 8. And then, what is my common variable? Y. Now, how many y's can I pull out? And this is actually very easy to identify. In any given polynomial, the most number of variables that you can pull out from every single term, as long as every single term has a variable, the same variable, you can pull out the lowest exponent value. So both of these y's contain at least 3 of the y's. So this is y cubed, this is y to the fourth. You can pull at least 3 that are common throughout. So your GCF will be 8y cubed. Now, let's extend this thought for just a moment. If I were to look at how this problem is structured, what would happen if I have 16y to the fourth plus 8y cubed, and I divided each of these terms by 8y cubed? Just thinking about how we combined how we're combining our concepts from dividing a polynomial by a monomial. What would happen in this case? What would that look like? Well, 8 goes into 16 twice. Y to the fourth and y cubed gives me just y. And this is perfect, so that is just a plus 1, right? Now, the concept of factoring actually builds off of this right here. So I've identified my GCF, and what I'm doing is I'm actually pulling that GCF out of the problem. So I'm pulling my GCF out from the entire problem, which then means I haven't changed my problem at all. That then means I'm looking at dividing my individual terms by this monomial, which is the GCF. I've pulled it out, and I'm left with 2y plus 1 when I've pulled out this term. Now, I know there's a lot of information that we need to process there, so I'm going to recap this one problem before jumping into another example. This is our original statement, 16y to the fourth plus 8y cubed. We said that what is common between these terms is 8y cubed. Now, if we were to take 8y cubed out of the problem, out from each of those terms, we pull it off to the side, and then we divide the individual terms of our polynomial by that GCF that we've pulled out. When we do that, this simplifies to 2y, this simplifies to 1, and here's our GCF that we pulled out. So we have factored our GCF. This is actually called factoring by GCF, or by greatest common factor. Okay, now again, I know there's a lot of information here. If you need to stop, rewind, etc., that's perfectly fine. But I'm going to move into the next problem. That way I can show you again step by step how this works. Okay, let's look at the second example that I have available to us. That is 5m to the fourth x to the third plus 15m to the fifth x to the sixth minus 20m to the fourth x to the second. Making sure I have everything written correctly, and I do. I now have multiple working pieces here, and I need to be very careful. So start with, what is the GCF? Meaning, what is common between all three of these different terms? So the GCF, starting with the coefficient, I see I have 5, I have 15, and I have 20. The greatest factor, the greatest term that I can pull out, since these are all divisible by 5, is 5. So I can pull out a 5. I see that I have m in every single one of these terms, so I can pull out an m, but how many? Here I have 4 m's, here I have 5 m's, here I have 4 m's. So the lowest exponent value that I have is 4, which means the most number of m's that I can pull out from all of these terms would be 4 of them. So m to the fourth. I also see that all of these terms have x. Now, I've got 3 x's here, I've got 6 here, and I've got 2 here. The lowest exponent would be this 2, which means the greatest number of x's that I can pull from anywhere is 2. So I've got my GCF. I have 5m to the fourth, x to the second. What would happen if I pull that GCF out of this problem? What does it look like? So we're going to go ahead and set this up as division. So I'm writing all of my terms from the original polynomial, and I'm dividing out this monomial term, which is the GCF. It's a little bit of writing, but that's okay. Now, I'm pulling out my GCF, so that's why I've put it out to the side. That's why I'm dividing it throughout my polynomial. I'm now looking at what does this simplify to in each component. So 5 goes into 5 perfectly there. M to the fourth, those cancel as well. X cubed over x squared gives me just x. Plus 5 goes into 15 3 times. M to the fourth, m to the fifth, those simplify to just m. X to the sixth and x to the second, those simplify to just x to the fourth. Over here, I have minus. I didn't drop my sign. 5 goes into 24 times. M to the fourth cancels. X to the second cancels. So I'm left with just that minus 4. This is all contributing to the fact that we pulled out our GCF. So I'm bringing my GCF value down. And this is now factored. Okay, so again, step by step, starting with my original, I'm finding out what is my GCF, my greatest common factor. I am then taking that greatest common factor, pulling it out to the side, which means I'm dividing each one of my terms by that common factor, simplifying them, and that gives me my factored version of this polynomial. Now, greatest common factor is an excellent way of factoring, especially if you have 4 terms in your polynomial. So far, we've worked with some 3-term polynomials that had some common elements to them. But we'll really talk more about 3-term polynomials a little bit later as we get deeper into factoring. For now, I want to show you an idea that is called factoring by grouping. Factoring by grouping. Now, factoring by grouping is very similar to what we were just doing, but it's a little bit of an extension, if you will. Extension of thought. Now, in this example, I have 4 terms. You can see I have 15x cubed, a negative 10x squared, positive 6x, and a negative 4. So I have 4 terms. And I have to ask myself, what is common here? I have 15, 10, 6, and 4. Well, there's nothing that's divisible between all of those terms. So there's no common coefficient that I could pull out. What about x's? I have an x here, here, and here, but I don't have an x there. Huh. So in this problem, there is no greatest common factor. So what do? It is factorable, but how? All right. Now, you're going to think this is silly, and you're going to probably be like, wow, he is really dating himself, because I don't even know if this app is in the market anymore. It probably is, but, on version 500 or whatever it is now. But do you remember the game Fruit Ninja? All right, yes, I know you're thinking, oh my gosh, Fruit Ninja, spent so much time on it. It's okay. Fruit Ninja, you throw up a piece of fruit, you slice it in half with your finger as you're swiping across the screen, and you're like, oh, I'm a ninja, a fruit ninja, hence the name. We're going to do the same thing, but I'm going to make you a math ninja. Here's how it works. Here's my 4-term polynomial. There is no GCF through the entire problem. That's the first thing I'm going to always check for. And if I have one, I'm going to pull it out. But I don't have one here, so here's what I'm going to do. It's time to become a math ninja. Wow. Boom! Math ninja. We're splitting the problem in half. And I can do that because I have 4 different terms. Now, looking at just this half, the first half, ignore all of that. I'm going to put my paper over there. Hopefully I can do that without losing any. Okay. Looking at just this first half, is there a GCF? Is there a greatest common factor between these 2 terms? Yes. Both of these coefficients are divisible by 5. So I'm going to pull out a 5. They also both have an x. The lowest number of exponents is a 2. So they both have an x squared in common. Now, that being said, if I were to pull out a 5x squared, Ask yourself, 5x squared times what gives me 15x cubed? It's the same thing as if you were to divide and work this out as well. So 5x squared times what gives you 15x cubed? 5 times 3 gives you the 15. X squared times x would give you the x cubed. So I'm simply skipping this intermediate step where I'm dividing out. You can absolutely still do this, but I am going straight to this format here where I'm factoring out that GCF. So if you're needing to see the intermediate step, go through and write it step by step where you're dividing out. I'm skipping that for now. My arm is also hurting, so I'm just going to come back to that second half up here in just a moment that I've partially erased. Okay. And I'm losing my paper. There we are. Okay, so I've pulled out 5x squared from this first term. What happens if I pull out 5x squared from this second term? 5 goes into 10 twice. That is a negative 10, so that's a minus. X squared and x squared cancel. So that's all I'm left with on that first half. Now, ignore the first half. Look at the second half. Is there a GCF? Is there something in common? Yes, both of these terms are divisible by 2. So I can pull out a 2. And I know it's going to be a positive 2. Let me share that secret with you. This is positive for my leading term of this half. So this is positive for the leading term of this half. I'm going to pull out a positive 2, meaning I'm not going to change any of my signs. Okay. There's no x's between them, so what happens if I pull out 2? Well, 2 times what gives you 6x? That would be 3x. 2 times what gives you 4? That would be 2. This minus did not change, so it is still there. And now I'm looking at my new problem, my new expression. I've pulled out a GCF from the first half. I've pulled out a GCF from the second half. But now I want to compare what's left after I pulled out those GCFs. That means I'm comparing these binomials. Are they the same? I have 3x minus 2. I have 3x minus 2. Hey, look at that. They are exactly the same. That's what I want. That's exactly what I want. So I am going to pull out this 3x minus 2 because from my new expression, that's a greatest common factor. It just happens to be a binomial. So what happens if I pull out 3x minus 2? I pulled that out. What am I left with? I have a 5x squared plus 2. That is it. That is factored. How do I know it works? You could always multiply it back out. And in this case, because it's a binomial times binomial, you could actually FOIL. So yes, you could do that just to check yourself. And I suggest doing that, especially as you're learning the concept here. Just check yourself by multiplying back out. You should always be able to come back to the original problem whenever you're doing factoring. If you don't come back to the original problem, double check your math because something went wrong somewhere. Okay, let's jump into another problem here just to get some practice. I am going to look at example 2, which is 6x squared plus 8xy minus 6x minus 8y. Okay, now, the first thing that I always want to do, and this is true of any factoring problem ever, the first thing I want to do is see if there is a GCF that I can pull out. In this problem, I see I have my coefficients are all even. It means I can pull out at least a 2. So 2 is definitely divisible there, divisible here, divisible there, divisible there. Nothing else is. So, excuse me, I'm getting marker dust or whatever you call this on my nose. It's like, okay. So I can pull out 2 from everything. Beautiful. What happens when I do? Well, this is 3x squared plus 4xy minus 3x minus 4y. So I just pulled out 2. I did a GCF factor. And now I'm looking to see if there's anything else I can do. What do I have left? Don't worry about this 2 for right now. We'll come back to it. What do I have left? I have a 4-term polynomial that has nothing in common. Math Ninja. Here we go. Boom. We did Math Ninja. Now we're looking at that first half. So I can pull out an x from both of these terms because 4 and 3 are not divisible by each other. So I can pull out an x, and I'm left with 3x plus 4y. Again, ignore this 2 for right now. If it helps, a good strategy is just circle it, put an arrow, and you know you're going to come back to it later, okay? But this is what we've got so far just looking at this first half right there. Let's look at the second half. 4 and 3 aren't divisible by each other. Nothing goes into both of them. There's no common variable. So what can I pull out? If you ever run into a situation like this where you don't know what you can pull out because there's nothing common between them, you can always pull 1. 1 is common between any number, any variable, whatever. You can always pull 1. So I'm going to pull out a 1, but, there's one other key little thing. My lead term here on this second half, my lead term is negative. So I want to change that sign. I like my lead term positive, so I am pulling out a negative as well. All right, what does that mean? That means when I've pulled out that negative, my signs will change in my factored form. So I've pulled out 1, which means these values have not changed, but my signs have changed because I pulled out a negative. So I have 3x plus 4y. Sweet. Now, just like before, we want to compare the items that we've been left with, the hand we've been dealt. These are exactly the same. I have 3x plus 4y in both of them, so I'm going to pull that out. I have 3x plus 4y. What am I left with? I have x minus 1. And hey, I see an arrow. This 2 did not disappear. It just goes out in front. And so there we have it. We have factored by grouping. We also pulled out a greatest common factor at the very beginning. Pretty easy, right? It's a little bit of a tedious process, but it's fairly easy. All right, let's do a couple more problems just to get our grasp on this. Okay, so I have, my next problem is 5xy minus 15x minus 6y plus 18. Again, check to see if there is anything common whatsoever in this entire problem. I have 5, 15, 6, 18. There's nothing divisible between all 3 of those. I don't have variables across the board, so there's nothing that I can do as far as a GCF. That means, looking at this problem, I have a 4-term polynomial. Become a math ninja. So I'm going to split it in half. Look at the first half. I have 5 that can go into both of these. I have an x that goes into both of these, so I can pull up 5x. When I do, I'm left with y minus 3. What about over here? I definitely see that I want to pull a negative out, so I'm going to go ahead and put that down. 6 goes into both of these, so I'm going to pull out a 6 as well. I'm left with a positive y because I pulled that negative, so I'm changing my signs, minus, changing my signs, 3. All right. Comparing these, They are exactly the same. So I have y minus 3, 5x minus 6. That's it. So you factored by grouping yet again. All right. Last problem for this section. It's a nice introduction to factoring. So this next problem, I have 6m squared minus 5mn plus 6m minus 5n. Ask yourself, do I have anything in common between these terms? No. There's nothing that's divisible between them. They don't all have the same at least one variable. So what do? Become a math ninja? It's a career choice. All right, so that being said, we're going to look at this first half. Nothing's divisible between 6 and 5, but I can pull m out of both of those. I know I can have 6m left over here minus 5n left over right here. Over here, I don't see anything that I can pull out. And my lead term's already positive, so what do I pull out? Remember, if you can't pull anything that is common between the terms, you can always pull 1. And in this case, I'm not wanting to change my sign, so I'm pulling a positive 1. That leaves me 6m minus 5n, because nothing has changed. Comparing my two binomials that I've pulled out, I have 6m minus 5n, which is exactly the same, so I can pull it out. I'm left with m plus 1. And that is it. Okay, very good. So at this point, that concludes this particular section, this little introduction to factoring. We've covered greatest common factor, and we've covered factoring by grouping. In the next lectures, we're actually going to get into a few more factoring methods, and so we will start building on these concepts from that point.